Hi. So in this video, I'll be talking about CatchCap. So CatchCap is a Python library which you can just pip install CatchCap and you can just directly use, which is basically for hallucination detection. So it acts as a middleware between your LLM response and the end user output that you will be showing to the user. So it basically catches potential hallucinations or maybe potential confabulations before they reach your end user. So let's talk about the problem statement here first. So LLMs hallucinate. We know that this is their feature, and uh, as much as we like this feature, we still want to like control this feature, because when we talk about the domains like law, medical, finance, and maybe some enterprise solution, their precision is very critical there. And hallucinations break trusts and create liability. That's like straight away point. So we need some kind of a guardrail or some kind of a middleware where we can just analyze which queries are getting which queries for which queries which LLMs are getting more hallucinated responses. So CatchCap kind of does that only. It's an open source library. Let's talk about how it works first. So what I'm doing is basically this is a much better way to understand it. So I'm generating n additional responses. So for this example, I will say for a one given query, I'll generate four total responses. I'll I'll compare those four responses and I'll be computing the semantic entropy between those four responses. So semantic entropy is basically measuring the variance across those responses. And how I'm doing that is basically for those four responses, I'm computing the basically the vector embeddings and then computing the cosine similarity and then doing the one minus cosine similarity to get the semantic entropy. And then I have an entropy threshold here, which is just a check. So this threshold will be inputted by the user, like whoever using the library. It would vary according to use case. And if entropy threshold, if your semantic entropy is higher than the threshold, then you can just flag the LLM response and say that this is very hallucinated, because here we know that model is not confident with the answer. So entropy means variance, and if the model responses have a lot of variance, that means that the model is not confident with its answer. But if the semantic entropy is very low, it's lower than the entropy threshold, then the model is confident enough with its answer. But one very good quality of LLMs is that they hallucinate even when they are confident with their answers. So we go to the next step where we are verifying it against the ground truth. So for here, like this is a very journal purpose library right now. So here I'm taking web search as a ground truth. So I'm doing the web search and getting the correct response for the initial query. And then I'm using LLM as a judge, which again you can configure which LLM you have to use as a judge, which will compare the web response and the first response generated by your initial generator LLM. And if they both are consistent, that means your output is not hallucinated. It's well grounded with the ground truth. But if they are not consistent, that means your output is not grounded with the ground truth, and it might have some confabulations or made up information or maybe hallucinations. And then the judge will give the final verdict of consistent and inconsistent. And from there, we can just configure whether the output is hallucinated or not. So again, this is a much more detailed way to like analyze that. So we have a query input here, we have four responses, then we compute the semantic entropy, and then we have, if the high entropy, then we flag right away. If we have low entropy, then we go for the ground truth, which is the web search, then the LLM as a judge, and then the verdict. So this is like pretty basic structure of catch cap. Like if I tell you like what is catch cap, this is catch cap right now. This is how I detect and uh, detect hallucinations. So like the entropy part is the detection part, and after that it's the generating the correct output for that query also. So semantic entropy check, again generating n responses, measure semantic variance across responses, high entropy, model uncertainty, flag immediately, we will flag it. And if low entropy, then model is confident and we will just go to the ground truth verification and then catch the cases where model is genuinely uncertain. Ground truth verification, we have web search. For web search, I have two options right now. So I have Tavli and I have CRXNG. So you can use both. For Tavli, you have to use your own Tavli API key. For CRXNG, you can just deploy it via Docker and use it the localhost URL. Then you might have a question that what if my RAG is hallucinating, like whether like I'm getting the chunk, I'm getting the response, but the response is not grounded by the chunk. So for that, I have another solution for you. Like it's not implemented into the CatchCap library yet, but I have plans for that too. But there is I have fine-tuned a context relevance classifier, which you can find on Hugging Face. I'll like attach the link in the description. So it classifies basically a response and a context. So it takes a response and a context and it tells you, it just basically gives a zero or one binary output on whether this response was generated using this given context or not. It's a very small 1 billion parameter model. It just gives outputs in yes and no. And it was fine tuned on 3.2 thousand legal domain examples. And it's very use case specific for now, but you can obviously test it out and see whether it works for you or not. You can also integrated it into the catch-cap library as a ground truth variable. So instead of web search, you can use basically this RAG detection, where this model is checking whether this response is generated via the given context or not. This is how it will look like, that you have the user query, then you give it to vector db gives out the context, then it goes into the llm generation, then we get the response, and then it goes to the context classifier, which gives a binary output of yes and no. If yes, then our output is verified, it's good to go. If no, then we can flag it, or we can just regenerate the response. This is the library. I'll just show you here only. So this is CatchCap. You can just go on exonlabs.live, and you can this is like complete documentation, how to install, what keys are required. Not all are required, but according to your use cases. Quick start, how to quick start. Semantic entropy, what is semantic entropy, how does it work, and what are the configurations for it. Log probabilities, we are also using log probabilities. So log probabilities will be token level probabilities, which gives us basically that how certain a model is for every token. So we get this access for OpenAI and Grok models, GROQ. So for those two, we are computing log probabilities also with semantic entropy to compute to detect the hallucinations basically. And then the web grounding, we have CRXNG and Tavli. We have both. You can play around with max results. You can play around with the synthesizer model if you are using CRXNG. So you can read about it. Then we have confidence scoring. So confidence scoring is basically how confident the model is. This is just the scoring that we are giving to the model response, which can help you determine whether how good a model is for a particular subset of your pipeline. So this is just a way to like give you scoring. You don't have to go into like semantic entropy and what are the entropy scores. You don't have to think about that. You can just straight away go with these confidence score and how confident your model is with its responses. Then there is the configuration guide, minimal config. Obviously, you can just put in a generator model, which you have the options out of OpenAI, Gemini, and Grok. So you can choose any model from these three. Only the non-reasoning models. We don't cater the reasoning models right now. Uh, so this is the most basic one. Rest of the values would be default, and this is the production config. Obviously, you can play around with generator, you can play around with semantic entropy, you can play around with log probs, you can play around with web search, you can choose the judge model, whatever you want. You can also like choose a different, you can use a generator model of OpenAI, and you can choose a judge model of Gemini. So you can play around with different combinations, what works for your use case, uh, according to your own data. And then this is a faster config, which you can just just put it in and just run it if you want to. Then model providers, obviously OpenAI, Gemini, Grok. And here are some examples how you can batch process. Also, we are doing parallel processing. So I told you that we are generating n responses here. So these n responses, their embeddings, and then the semantic entropy computation, this all is happening in parallel. So it's not a sequential process. So it will take time, but it's not taking time like in the like as for every response. It is processing in it is processing asynchronously. So that's sorted. You can batch process your queries, and there is a good enough error handling for now. You can update your judge prompts basically. So we have a inbuilt judge prompt which you can see obviously in the code. You can update it according to your use case. If you want your judge model to behave in a certain way, you can just update it, and it will just work on the go. And then some more details about some key features and all, and you can just straight away go to PyPI from here if you want to. It's the Python package. And if you want to contribute to it, you can just straight away go to the GitHub. Mhm. Yeah, so you can just go and just raise a PR, raise a issue, try, test it, like try to break it, whatever you want to do. Uh, I'm open to everything. So this is all about catch cap for now. And then let's talk about trade-offs for now. So I've built this catch cap, but I know the trade-offs. I was initially thinking about building it in stealth and like maybe I'll be selling it to enterprises. But then I realized that this is only a harness. This is a harness which you can use to basically use between your LLM and the end user. But you cannot use it on production, and it is costly and slow. So time complexity increases by order of n, almost closer to order of n, because you are generating n responses, and then you are also giving it to the web search, and then in web search Tably is much faster but CRXNG is much slower. Then you give it to a judge model, then judge model takes the time. So it's like a series of tasks that happens. So like time increases and the cost also increases because you are making multiple API requests. So per query you are generating n generations and everything. If we talk about like this is some metrics that I computed like randomly. So latency wise, if you have standard LLM, it will take 1 to 2 seconds. With patch cap, it goes up to 10 to 20 seconds depending on the model you are using. Then token usage also increases by n plus 2x. And the cost per query, it depends on the model which you are using. This one is for a particular model. Then hallucination risk will be low on catch cap and high on standard LLMs, and precision would be variable for standard LLMs and high would be for the catch cap. So these two metrics, I'm not talking like just out of the box. Basically, I've tested it on a very small test set of 12 queries. I'll be testing it on a much larger query set, and I would be basically benchmarking it against other hallucination solutions out there, and I'll be seeing how well it performs. But yeah, this is this might be slow, this might take more tokens, this might be costly, but you can use it to basically analyze where your pipelines are hallucinating, and you can just tweak a little. You can get a good data about what is happening wrong in your systems. So let's talk about version 2 updates. So for version 2 updates, firstly I'm thinking about an internal, basically implementing integrating a RAG too. So I told you that I have a web search in place with my uh, basically for the ground truth. I'm also like very much interested in adding RAG too. So if someone has a database already with them, or they might not have a database, they have some documents and they want to create a RAG with it. So I'm like planning to add that RAG as a grounding truth, as a grounding check. So basically for every query response, you will be checking with the RAG outputs that whether it's correct or not, and then moving forward. Just changing that, the web search part with the RAG search part, basically adding that feature. Then I want a caching layer here. So basically, if queries are repeated, so basically models hallucinate on similar queries, and once you identify them, you can just very easily cache the correct response for those queries, even variation of responses for those queries, and then just fetch those correct responses for those queries, and do not generate again and again by LLM. This will reduce the hallucinations by a lot. And third is a observability dashboard, basically a monitoring platform to handle the metrics, detection patterns, which queries trigger the hallucinations more. Basically, again, inputting the correct responses and analyzing everything, just a dashboard for it, and use the monitoring data to optimize the caching, which is interrelated, these two features. So these are the features I'll be working on next. If you have ideas about any more features, if you have some cool ideas, new ideas, I'll be happy to talk about them, and you can just add them in issues maybe, or just hit me up. Looking at some of the examples, so the classic number of hours in a strawberry question, that model response was there are 2 hours. Then these are the analysis metrics. Then the corrected response from the web search, we get that there are 3 hours. So this is a way that flagging could work for hallucination. This is example where the model outputted correctly, so we just let it go. We didn't like flagged it or something. That 9.9 is greater than 9.1, again a classic hallucination question. So like this is how like catch cap would work in like simple Q&A type systems. But I would want to build catch cap for like much more nuanced systems, for say for example like data generation. So if you want to generate synthetic data set for some say medical like model, you are building a medical specialist doctor model, and you want to like prepare a data set for that. So you don't want hallucinated outputs in your data set. So for that you can use this library as a double checker, and you can just this can act as a very good harness for your very good quality data set preparation. This would be open. This will be open source. This is open source project from my side. Contributions, issues, PRs, anything you want. You want to collaborate. You want to talk about it. If you are facing this problem, this is just straight away built for the community. I learned everything I learned about hallucinations was from open source things, open source papers and all. Uh, Open source papers, a bit controversial, but yeah. Uh, so I'll be open to like I'll be very happy if somebody would want to contribute. I presented this catch cap. Basically, I launched this catch cap recently on a IRL event in Delhi. So there were like 30 to 40 people there. So like it was a great experience. I pitched this same pitch I pitched there. So I got a good response. Many people were interested in it. But then I thought that why not just extend it and just put it on YouTube. So I'm just doing that, explaining what I'm building and explaining my idea. If you have any more ideas, if you have any corrections, maybe some new kind of technique that you might have encountered for hallucination detection, then you can just hit me up at my X account, where I'm moderately active, or you can just drop me an email. This is exonlabs.live. You can scan or just type in, and you will just go to this URL basically, where you can just read the docs and try and test it and then give some feedback. Yeah, that's it for this video, I guess. Yeah, nothing more from my side. Thank you guys. Bye.